Hello students, in this video I am going to give solutions for previous video questions. I gave 3 questions in previous video, Grignard reagent. Okay, so what is the first question? Acetaldehyde with Grignard reagent. Acetaldehyde with Grignard reagent. So what is the Grignard reagent we used? CH3MgCl. Yes, in previous video we have discussed more about Grignard reagent, right? So Grignard reagent acts as base in some particular reactions and some particular reactions it acts as nucleophile. Now in this particular reaction also acts as nucleophile, carbonyl groups, carbonyl compound, this is aldehyde. With the carbonyl compounds, Grignard reagent acts as nucleophile with carbonyl compounds. This is exactly carbonyl group. If end with hydrogen, it must be hydrogen, that is aldehyde. If there is no hydrogen, both are aliphatic groups and aromatic groups, that is ketones. So finally here with carbonyl compounds, Grignard reagent acts as nucleophile. Okay. Now look into this. Nucleophile. So nucleophile always search electrophile, electrophile search nucleophile, acid search bases, base search acids. That is the reaction. Nucleophile, electrophile, that is organic chemistry connectivity questions. That is organic chemistry reactions we are learning, right? So now here carbon and oxygen. Who is more electronegative? Oxygen. The pi electron shifts towards oxygen side such a way partial negative charge, partial positive charge develop. This is partial positive charge. Yes, that's all. Now nucleophile search, this electrophile reaction starts. This is plus. Wherever plus is there, plus and minus. That's all students. This is your product. CH3 CO minus MgCl. And what about this guy? This hydrogen as it is I have written. And who came and attack here? CH3 group. That's all. And further steps we'll do hydrolysis. So you'll get product. What is this? CH3 CHOH CH3. So in previous video I gave conclusion points also. What are conclusion points I had given to you students? Remembered? So what is the conclusion points? So acetaldehyde will give secondary alcohol. Secondary alcohol. If they ask to name what is this? 2-propanol. 2-propanol. Next. Question 2. This is question 1 solution. And question 2 what I gave? Propanone. Hope most of the students have solved this question. Propanone with Grignard reagent, CH3MgCl. This is also carbonyl compound, no? Yes, definitely it acts as nucleophile. So this is electrophile. Reaction starts like this. That's all. If you catch that main point, next product it is easily you can write MgCl. And what about this guy? Yes, CH3. And already one CH3 is there, that's one. And who is coming newly? That is CH3. After that, we are doing hydrolysis, students. Hydrolysis means we are bond breaking. Here, bond breaking, we will get the product. Okay. So what is the conclusions I had given in previous video? If you will take propanone, that is acetone, we will get tertiary alcohol. Right. So that is your answer. This is your main product. OH, CH3, CH3 plus byproduct is MgCl, OH. That's all. So conclusion points in previous video, detailed explanation in previous video I had given. For previous video I gave some questions, for that solutions only I had given. If you have any queries and doubts, please watch that one and afterwards you come back and try these solutions and check. Okay, now next one more question I had given. What is that question, student? With carbon dioxide. This is one of the preparation methods for carboxylic acids we used. right? So check it. CH3MgCl. Okay, Grignard reagent with carbon dioxide. You can write expanded form. That's it. If you write like this, definitely you will get some points. See, between carbon and oxygen. Now see, again same point. Grignard reagent in this particular reaction acts as acid, acts as base or else nucleophile. We have to check it now. Here there is no hydrogen, right? So then definitely it acts as nucleophile. Why? Because carbon and oxygen, two different electronegativity is there, two different electronegativity negative atoms is there, definitely polarity it will develop. That too oxygen is the second most electronegativity. So pi electron shifts towards oxygen side, such a way partial negative charge, partial positive charge develop like this. That's all. So we created electrophile. So this is what students Mg plus. Yes, this CH3 will go and attack here. This Mg plus will go and attack here. That's it, your product. See, right. C, first one, you can write this one. C, okay, and this oxygen normally you can write a double bond O, and this oxygen O minus, right? So whatever minus is there, positive charge, positive group will come and attack. That's it. And what about this guy? This CH3 will come and attack. That's it. Now further step, it will undergo hydrolysis. That's it. So hydrolysis also easily how you can write H plus OH minus. So H plus here, OH minus here. That's all. CH3, C double bond O, OH plus MgCl. See, every chapter, just you recall all the chapters. In first chapter, second year, first chapter, what is the first chapter? Alkyl halides, right? In alkyl halides, we are preparing Grignard reagent like CH3Cl plus Mg, and in presence of dry ether, we have taken in previous video also CH3MgCl. Yes, in first chapter, we are preparing Grignard reagent. And what about second chapter? Alcohols, especially alcohols, phenols, ethers also there. Alcohols, phenols, and afterwards carbonyl compounds. Right, carbonyl compounds means again aldehydes and ketones, and afterwards acid, carboxylic acid, and the last one is amines chapter. So how these are the major chapters in second year, right? See, in alkyl halides we are preparing Grignard reagent. There also we are studying alcohols, phenols, also Grignard reagent questions we have. So in alcohol, phenols are acidic in nature, no? With this alcohols and phenols, Grignard reagent access, tell me students, access base. Right. With your carbonyl compounds, GR, Grignard reagent access nucleophile. Right. So, and acid chapter, carboxylic acid, any acid you can prepare. If you take CH3MgCl, you will get acetic acid. If you will increase the chain here, if you increase the chain, propanoic acid means increase the chain, butanoic acid, like number of acids you can make. So, in acid lesson, GR, Grignard reagent access, these two chapters, Grignard reagent access, like that. That's all students. If you have command this one, so good number of questions, it's very easy for you, Grignard reagent. Okay. So now next one more, little high order questions. Reversal of charge is possible. Sometimes no, excess Grignard reagent we are using. When we will use 2 moles of Grignard reagent, that is also I can show an example. If good living groups are there, so then reversal of charge possible. Students, first note down, note point, note 1. What is the note 1? Note 1, see. Good living groups. Good living groups are there. Reversal of charge possible. Reversal of charge possible. Okay, what are good living groups? Let me list out here. So OH group, OR group, Cl group, and all halogens, Br, iodine, like this. This type of groups are there. These are good leaving groups. Good leaving groups is there, then reversal of charge possible. So I'll take one example and I will explain this one. Then you can understand more. So let me take acids and acid derivatives. Anything you can take it. So let me take acetyl chloride. Okay. So I am taking acetyl chloride, acyl chloride plus Grignard reagent. So they will ask, acetyl chloride reacts with the Grignard reagent. How many moles of Grignard reagent is required? What is the product? What is the product name? Is it tertiary or secondary, primary alcohol? Different ways they can frame the questions. Okay. Now look into this. CH3 minus, right? So it acts as nucleophile or electrophile. This is acid derivative, no? So this is it is not giving hydrogen. It is not giving see carbonyl group is there. C double bond O group is there. C double bond O group is there. Definitely it acts as electrophile only because oxygen it takes more electrons towards that side. Then partial charges develop electrophile and nucleophile. Then reaction like this is the first step, right? So write the first step CH3 CO minus MgX. X means you can take it anything. If you will take chlorine, yes, chlorine you can write. Okay. Now Cl. Next, just now what we have taken CH3, that is also you can write. Okay. That's all, students. Up to here, so I hope everybody is clear. Now, reversal of charge possible. Students, this is one of the most important steps. Then, reversal of charge. Reversal of charge. See, so if suppose this charge is coming back, reversal of charge is nothing but this charge is coming back. So once charge is coming back, just imagine this carbon how many bonds. Here one bond, new bond coming, already has one bond, totally two bonds, 3, 4, 5. Is it possible to exist carbon? No. Carbon maximum valency 4, we all know, right? So then leaving group, it leave one group. That's it. What I gave here note point, look into that once again. If good living groups are there, reversal of charge possible. Yes, he is a good living group. That's why reversal of charge possible. These two will go. That's it. What are the byproducts? MgCl2, right? So now main product. CH3, C double bond O, CH3. This is your main product. Is it your final product? Is it your final product? No, it's not your final product. See, again active site generated double bond like this. See, so then you again it will take one more mole of Grignard reagent. If active site is there, further addition will take place. Further reaction will take place. See, so one more mole of Grignard reagent we can use. CH3 MgCl. This is minus, this is plus, right? So this will go and attack here. That's all like this. Now try to write the product, students. CH3 CO minus MgCl, then CH3. Now check it. Reversal of charge possible or not? In that list, what I gave, good living groups. In that list, CH3 group is there? No. So what is the note point here? Note point 2. If CH3 group and hydrogen atom, hydrogen is there. CH3 and hydrogen, methyl and hydrogen groups are not good living groups. Not good living groups. Some special conditions are there, then only it is possible, like Cannizzaro reaction. Cannizzaro reaction mechanism time, this is a special mechanism. It follows third order kinetics and nucleophile importance, 2 moles importance is there. According to kinetics also it is third order mechanism, third order kinetics. So I'll explain some named reactions also coming videos. There I will explain this detailed Cannizzaro reaction. Hydride shift takes place there. Hydrogen would leave. Hydrate shift takes place. Reversal of charge possible in Cannizzaro reaction, but hydrogen is good living group there. Hydrogen is good living. Hydrogen is living group. Hydrogen is living group. That is special case. Only some particular reactions, especially Cannizzaro. Otherwise, normal cases, CH3 and hydrogen are not good living groups. See, whenever you will write Grignard reagent, direct this you can take it point. So see here. So good living groups is not there. That's all. You will do further hydrolysis. That's all. You will get answer CH3, 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 and what is this? OH, right? That's all. Tertiary alcohol. This is your end product. End product. Intermediate active sites generated like double bond and all. Definitely it takes one more. So I am giving one question, students. Everybody try to do this one. Next video I'll give the answer. Okay. So see, CH3 C double bond O C2H5 plus CH3 CH2 MgCl. Okay. So try to write the product. Next video I am going to give solution. Okay students. Thank you. Thanks for watching.